Hello everyone, so today I'm going to be showing you how to balance chemical reactions. The first question you should be asking is, well, why? Why do we do it? And the answer to that is simply to maintain the law of conservation of mass and matter. Now remember, we talked about the conservation of mass and matter in class the Friday before March break. What this is basically saying that mass is conserved from before a reaction to after a reaction. If you recall grade 9 science and the review we did, we know a reaction happens because there's often a few visible signs of a reaction. So things like a precipitate is formed, a gas is formed, color change, odor change, change in energy. So things like this. Those all indicate that a chemical reaction has occurred, and we need to balance these chemical formulas or else we're breaking the laws of the universe. So today we're going to talk about balancing. So something that I've written down here is Hofbrinkel. Now Hofbrinkel is pretty important for understanding chemical reactions and being able to predict them. I've had you predict chemical reactions, but we didn't really get a chance to talk about it together, and so I never got a chance to talk about Hofbrinkel. Now, Hofbrinkel is important because Hofbrinkel is how we remember what the diatomic molecules are. So when predicting a chemical reaction, let's just say we have HCl plus Br2, and we need to predict the products. Remember, these are the reactants, and these are the products. So we need to predict the products. The first thing that I like to do is I like to notice what's going on in our reactant side. So what's going on over here is we have one compound that's together, and we have one guy all alone. And so I know that something has got to switch, okay? So I know, just from practice, that this is a single displacement reaction. I know that because we have one compound, and one lone guy, so an atom or a molecule. And this molecule will almost always be a diatomic. So when switching, I know that like replaces like. So chlorine has a charge of -1, bromine has a charge of -1, so those two are going to have a little swapsies. So we have HBrCl. Now it's important to create the correct formula for our products. Hydrogen has a charge of +1, bromine has a charge of -1, which means, as it's written, is acceptable. But chlorine right now is unhappy because it's all by itself with a charge of -1. So Hofbrinkel are atoms that pair together. Chlorine, notice right here, Cl, is one of these. Anytime we see one of these atoms by themselves, we know they're not actually by themselves. They always pair up with themselves. And so to describe that, we added 2 underneath, a subscript of 2. So I wanted to go over that while we had the chance to do it. The next important thing I want to talk about is a bit of terminology. So we've already talked about subscript, and that subscript tells us the number of atoms in that molecule. So in the case of Cl2, there are 2 chlorines. Excuse my spelling, you know it's not very good. Or in the case of HCl, the absence of a subscript tells us that there's one of the atom. So here we have one chlorine and one HCl. And this should be, or 1H, sorry. And this should be a review from grade 9. What else should be a review is that idea of coefficient. Now, of course, coefficient is a term that you should have experienced in math as well as grade 9 science. The coefficient is the number that comes before the compound. So it's this number right there. And that sort of applies into the compound. If we have 2 HCl, then we have 2 hydrogens and 2 chlorines. Let's say we had H2SO4. Now we know that SO4, sulfate, is a polyatomic ion. Let's say we add a coefficient. Now we have subscripts and coefficients going on. So here we have 4 hydrogens because the 2 and this 2 are both being applied to that hydrogen. If we're looking at the number of sulfurs we have, then we only have 2. Notice how I'm using this coefficient to expand out, just like you would do in math. And finally, we have oxygen. Notice the oxygen has a 4 subscript. So right off the bat, we're starting with 4 oxygen, and then we apply that 2, so 2 times 4 is 8. So this is all about counting our atoms. This is important as we move to balance. Okay, so I've rewritten our example down here, and now I want to talk to you about balancing reactions. So we have a left side and we have a right side. And the left side is, well, on the left-hand side of the arrow, and the right side is on the right-hand side of the arrow. So on the left, on both sides actually, we have hydrogen, we have chlorine, and bromine. And I just want to count how many of each we have. So the first thing is hydrogen. We have 1 hydrogen on the left side and 1 hydrogen on the right side. So far, those are balanced because the left side is equal to the right side. Now let's look at chlorine. Chlorine has 1 on the left side, but 2 on the right-hand side. Next, let's move to bromine. Bromine has 2 on the left-hand side and 1 on the right-hand side. So right off the bat, you should notice that bromine and chlorine are not balanced. Okay, so over here on the right, I've written out the steps to balancing. The first step is to balance the metals, the next, the nonmetals, the next, hydrogen, and finally oxygen. And then of course you have to check, just like you would check a problem in math. Now, this is not the only way to do it. It is the way that I like to follow. If you use a different method, that's totally okay. But it's just one way to sort of organize your thinking. So let's look at our problem over here. You'll notice that we don't have any metals. We have hydrogen, chlorine, and bromine, none of which are metals. So we've already done step 1 effectively. What you'll notice is we do have a bunch of nonmetals that are not balanced. Now what it means to be not balanced is these numbers aren't the same on either side. So we're going to balance our nonmetals. To do that, you need to add a coefficient in front of these numbers. So I'm going to just start with chlorine because it's next on my list, and that works perfectly fine. So in order to balance, what I notice is that I have 1 chlorine on the left-hand side and 2 chlorines on the right-hand side. So I need to add a coefficient of 2. What this 2 does is it now applies to the chlorine. So instead of 1, I have 2 chlorines. It also applies to the hydrogen. So instead of 1, I have 2 hydrogen. So it changes all of the atoms in the compound. Well, now we have chlorine balanced, but hydrogen is out of whack, and bromine is still out of whack. So I'm going to go to the other side of the reaction, because over here it says that I have 2 bromine on the left-hand side and only 1 on the right-hand side. So I'm going to find my bromine on my right-hand side and add a 2 there as well. What this does is it now changes this bromine to a 2 and this bromine to a 2. So, according to my list, I have balanced the nonmetals. I've balanced the hydrogen. We don't have any oxygen, so effectively I've balanced it. And now we need to check. So to check, what I'm going to do is just double check. So, counting this way, I have 2 hydrogen, check. And then I go to the other side, I have 2 hydrogen over here. Back to the left-hand side, I have 2 chlorine, and I have 2 chlorine right here. Bromine, I have 2 right here, and I have 2 bromine right there. So 2, 2, 2, 2, 2, it is now balanced. Notice the only thing that I've done is added coefficients. Do not change the subscripts, only add coefficients. So it's worth noting that some of you may be able to just do that in your head. I use this sort of T-chart just to keep track of all the ions and make sure that it's balanced. It's also useful to check. Again, some of you can do this immediately, some of you will take time to get to that point, and that's okay, it doesn't really matter, but I'm showing you the steps that I take to make sure that I'm doing it properly. Let's look at another example. Okay, so I've written out another example, and first thing, we need to tally up how many atoms do we have. On the left side, we have 2 hydrogen, and we have 2 oxygen. On the right-hand side, we have 2 hydrogen, and we have 3 oxygen. So right off the bat, we know that oxygen is not balanced. If we check our steps, we don't have any metals, we don't have any nonmetals, all we have is hydrogen and oxygen. Sometimes our steps require us to go back and forth a few times, so don't be surprised if this is what we end up having to do here. Now, notice we have 3 oxygen on the one side, which means we need to add oxygen on the left-hand side. So I'm going to increase my current coefficient from 1 to 2. So right now we have 2. That changes our hydrogen to be a 4. And it also changes our oxygen to be a 4. So now both of them are misbalanced. We have a few choices here. We can try adding a coefficient in front of the oxygen, or we can try adding a coefficient in front of here. Take a moment, pause the video. Which one do you think would work better? Okay, did you pause the video? Well, I think that adding a coefficient in front of this water molecule will be easier for us. So let's give that a try. I'm going to change the current coefficient of 1 to 2. So what that does is it now makes this hydrogen have 4 on this side, and now we have 2 oxygen here and 2 oxygen here with a total of 4. Sorry if it looks a bit messy. I'm still figuring out the program and it's not letting me erase certain things. How about we double check what we have right now? So over here we have 4 hydrogen, because 2 times 2 is 4. Over here we have 4 hydrogen, because 2 times 2 is 4. Over here we have 4 oxygen, because 2 times 2 is still 4. And over here we have, hopefully, 4 oxygen. We have 2 times 1 is 2, plus 2 is 4. And we are now balanced. So I'm going to give you another problem, and at this point I'm going to let you choose whether you want to give it a go by pausing the video or continue watching for another example. Okay, So here's the problem right here. Aluminum is added to iron nitride and produces aluminum nitride and iron. So right off the bat, you should recognize that it's a single displacement reaction. Anyhow, now's the time to pause the video and try it on your own, or if you want, just keep watching. And we will work through it together. So, together, left side, right side, I always set this up. We have aluminum, we have iron, and we have nitrogen. Simply count what we're starting with. We have 1 aluminum, 3 iron, 1 nitrogen, 1 aluminum, 1 iron, 1 nitrogen. And I copy-pasted our steps down here. So here we're working with a bit more. Step 1, balance our metals. In this case, our metals are aluminum and iron. Aluminum is already balanced. Iron, however, is not. So what I'm going to do is balance our metals. To do that, I need to add iron on the right-hand side. Right now we have 3 on the left-hand side and 1 on the right-hand side. In order to make this equal 3, I'm going to simply add a coefficient of 3. Now this changes the 1 to a 3. Notice aluminum is 1 and 1, iron is 3 and 3, nitrogen is 1 and 1. That's it, it's balanced. If you tried this on your own, how did it go? Did you get the right answer? Did you overcomplicate things? Sometimes that happens. Okay, I've written out another practice problem. We have magnesium chlorate produces magnesium chloride and oxygen. If you'd like to try it on your own, now's the time to pause the video and do that. If you'd like to work through it with me, keep watching. So, the first thing we need to do to balance is count up our atoms. Magnesium, we have 1 on the left-hand side and 1 on the right-hand side. Chlorine is a little bit tricky because we have a 2 outside the bracket. This 2 applies in, and so now we have 2 chlorine. On the other side, we have 2. Oxygen is tricky as well, but we have 3 times 2 giving us 6, and we have 2 on the opposite side. So first we need to balance the metals. The metals in this case are magnesium. Magnesium is already balanced. Then we need to balance the nonmetals. Our nonmetals here are chlorine. Chlorine is already balanced. Oxygen, of course, is a nonmetal, but note that we ask you to balance it separately, and that's because sometimes it acts a bit differently, and often hydrogen and oxygen will actually get balanced together. It just so happens to work out that way often. So the thing that we need to balance in this case is oxygen. We have 6 over here and 2 on the right-hand side. We need to make this 2 equal 6. So if we add a subscript of 2, and a coefficient of 2, and it already has a subscript of 2, then our total oxygen will be 4. So we know that can't be it. If we add a coefficient of 3, and we already have 2 oxygen, then we get a total of 6. So that's what we're looking for. We're going to add a coefficient of 3, which gives us 6 oxygen. Now we can double check. We have 1 magnesium and 1 magnesium, 2 chlorine and 2 chlorine, 6 oxygen and 6 oxygen. How'd that go for you, for anyone who did it on your own? I hope you're starting to understand. I have one last thing to teach you. So, I've written our final example down here. Now, I've chosen this example because we have some polyatomic ions. Notice we had a polyatomic ion up here as well. The difference is that this polyatomic ion appears on the left-hand side as well as the right-hand side, whereas our polyatomic ion from the past example only appears on the left-hand side and not on the right-hand side. So here's a trick that makes balancing a little bit easier for you when you're working with polyatomic ions. And that trick is to keep it together on our chart. So we have potassium, we have bromine, we have iron, and when the polyatomic ion exists on the left-hand side as well as the right-hand side, you keep them together. And so when counting, we count them as one. So with this in mind, give this balancing problem a go on your own if you'd like, or keep watching to work through it with me. On the left-hand side, we have 1 potassium. On the right-hand side, we have 1 potassium. On the left-hand side, we have 1 bromine, and we have 3 bromine. Iron, we have 1 and 1. And hydroxide, that's what this polyatomic ion is called, we have 3 and 1. Okay, so this subscript of 3 applies to the whole polyatomic ion. Going back to our steps, we have to balance the metals first. We have potassium and iron as our metals. They're already balanced. Then we need to balance the nonmetals, bromine. So right off the bat, you notice that there are 3 bromine on the right-hand side. So to balance that, I'm going to add a coefficient of 3 on the left-hand side. That makes potassium become a 3 and bromine become a 3 on the left-hand side. So we've completely flung our potassium out of whack, and now we need to balance that. Same thing as before, I'm going to add a 3 over here. So that causes this potassium to become a 3. It also causes the hydroxide to become a 3. Notice it's balanced, so let's double check. We have 3 potassium over here and 3 potassium over here. We have 3 bromine over here, and we have 3 bromine over here. Iron, we have just the 1, and just the 1 over here. Hydroxide, we have 3 over here, and we have 3 over here. And so now we are balanced. It's important to note that you could have solved it by finding the number of oxygen and the number of hydrogen. It definitely works. I just find it a bit more complicated than it needs to be. So that's balancing for you. Please give me an email if you need any help with this. Good luck. Have fun.